Number one, I see a p of x function, I see a q of x function, and I see that if I multiply these two, it should get me this equation over here. So, I'm already pulling up Desmos, and I have our three formulas plugged in here. We have our p of x, our q of x, and then our p times q gets us this. So there's going to be an easiest possible way to solve this, and that is, well, if I just take this equation and I multiply it by this equation, we can make a regression to make it equal to this equation, and it should automatically give me my k value. So I know you can't copy and paste on your actual, Bluebook Desmos software, but just for the sake of time, we'll grab this, we'll put parentheses here, and then our regression to this, because it should be equal to it. And then all I have to do is change my x to x1, and we should see what our value of k here is. And there's a regression, our k is 5. Just in case sometimes it doesn't work, all you'd have to do is give a couple values here for our x. But you see we get the same value, k is 5. That's it for this one. Number 2, I see a g of x function. For any positive integer k, the value of g of k is r% less than the value of g of k minus 1. So let's make this sound a little easier. Say this was 10, and say this was 15. Well, 10 is r% less than 15. Well, that doesn't sound so bad. To get the percent less, or the difference, first we need to get our numerical difference. So I do 15 minus 10. That's going to get us our difference of 5. And for what to divide by, I know it looks like we're starting with 10, but they're actually comparing 10. 10 is what percent less than 15. So 15 is actually our foundation here. And all I have to do on Desmos is copy this exact format. So if we pull Desmos up, I already have my g of x typed in. And then I just replace the 15 and 10 with my two functions. So g of k minus 1 minus the g of k. And then I divide all that by g of k minus 1. And they just said k is a positive integer. I can just make it 1. There's my percentage there, 0.69 in decimal form. But just to jump back to our worksheet, I should see when they mention percent, they want it as a whole number. So it's just going to be d here. Number 3, one of the factors of this function is mx squared plus n, where m and n are positive constants. Which of the following is a possible value of m times n? So I'm thinking, if I times my a and my c value, and I get a number, there's going to be two factors to this number that add to 97. I can do factor by grouping, and I can see what my m and n values are. So I open up Desmos, and I already have my a times my c value here. And I'm thinking, well, if I take my a times my c value, and I divide it by some factor, it should result in the other factor that multiplies to get that, right? I also know that my two factors should add up to my b term, which is 97. That's what's super nice, is I can just use Desmos to get my two factors here. It's going to be 42 and 55. So I jump back to my paper here, and I write down 42 and 55. And then we just do a little factor by grouping down below. Let's get rid of this. And we have 30, x to the 4th. And I'll pair the 42, x squared, with that. And then plus my 55, x squared, with the 77. And then all I have to do is, out of this, I can take 6x squared. Out of this, I can take 11. And then down below, finally, we have 6x squared, 5x squared plus, what is that, 7? And then plus 11 times, take 11 out of that, 5x squared plus 7. So it worked. And our final form down below is, we pair these two together, 6x squared plus 11 times 5x squared plus 7. So my only possible multiplication is 6 times 11, because look, they want the m and the n. 6 times 11 would get me 66, not a possible answer. 5 times 7 gets me 35. It looks like it's going to be C here. Number 4, I have a p function, a q function, and an r function. And down below I see they take p, they multiply it by q, they subtract r, and it's equivalent to the standard form. So you already know I'm jumping on Desmos, and I have my first three functions plugged in, and I kind of match their format down below. So again, we have p times q, subtracted r, and then it should be equal to this standard form. And this is where you know you want to use regression. We set it equal using regression. We replace our x's with x1. And it gives us some values here, but remember you always want to plug in some values for x. So I'm going to make it equal to -2, 0, and +2. And I see my b value right here, -29. Let's double check it's on our worksheet. And it looks like it's going to be answer choice B here. Number 5, a number p is 130% greater than a positive number q. So this is already kind of like a transcribing problem where we want to turn our context into equations. So I'm going to say p is equal to, this phrase can be tricky. So 130% we want to write as a decimal, so it would be 1.3. But remember that greater than or more than, you have to add an extra 1. If it was of 130% of, then it would be 1.3. So since it's greater or more, it actually turns into 2.3, then a positive number q. And then our second equation, a number r is equal to, turn it into a decimal, 0.7 less than the number p. Oops. So 70% less means it would be 0.3 p. And then finally, they want the number r is something q. So since they want r and q in my final equation, I actually want to get rid of p. So I can just substitute. We can say r is equal to 0.3, replace p with what p is equal to, 2.3 q. And finally, 3 times 2.3 would be 6.9, but since it's 0.3, that just becomes 0.69 q. And my final answer here is just going to be C, the number in front of Q. Number 6, the table shows the distribution of players in a certain city by the number of hours of video games they play per year. We have a little chart with our percentages and then which amount of hours they kind of belong to. And down below, if a person in the city is selected at random, which of the following is closest to the probability that the person plays greater than 600 hours, that's right here, per year, given that the person plays at least 100 hours. So this is going to be a given probability problem, but we want to make sure we're okay with probability first. So probability is just what we want divided by our total, right? Usually our numerator is pretty pronounced, what we want, and it is. It's going to be greater than 600 hours. So we know our numerator here is going to be 18%, or we'll just do 18 for now. And normally our total here would just be this plus that, which would be 100. And that's how they got this in the first place. But this one's different because they're giving us, we actually know that the person they're randomly guessing from plays at least 100 hours. So that would not include people that played less than 100 hours, or it kind of gets rid of that 20%. So we still have the 18 from the people that played more than 600 hours, but our total changes to not include that 20%. So it's actually 18 over 80 now, and if we divide that, you should get something close to 0.22 or 22% here. Number 7, they give us a data set here where we don't know m, n, and k, but they do tell us it's in ascending order, which means this is our smallest number leading up to our biggest number k. They say the mean is 35, which we can start to form an equation. So m plus n plus k plus my other 4 numbers, which should sum to 133. So if I add everything up and I divide by how many numbers there are, 7, we should get our mean of 35. I can then try to simplify it. I can multiply both sides by 7. These 7 should cancel out. And then if I do 7 times 35, that all is going to be equal to 245. So m plus n plus k. And then instead of me having to rewrite this, I'm just going to also subtract 133 to both sides. So if I subtract 133, I should get these 3 sum to 112. So much nicer looking. They got to give us some extra info though. They tell us the median is 22. So it's nice. They gave us an odd number of numbers. Remember, your median is your middle. So whenever there's just one number in the middle, that has to be 22, right? So if n is 22, what I can now do is subtract 22 from both sides. So I get my final equation, m plus k is equal to 90. But we still need a little bit more. And they say the range is 60. Your range is just your biggest number minus your smallest number. So k minus m is equal to 60. And instead of having to do any math by hand, I'm just going to pull Desmos up and make those both xy equations. So x plus y is equal to 90. And then I made ky, so y minus x is equal to 60. Go ahead and find my intersection point, and it looks like my x, y is 1575. Let's go ahead and get rid of that. So my m is 15, my k is 75. They want the value of k, just going to be c here. Number 8, in each of the following data sets of 5 values, k is a constant. Which of the data sets has the largest standard deviation? So vocab-wise, remember to deviate is to change. If I have something planned and I deviate from that plan, I'm kind of changing away from it. So your standard deviation is just how much change there is across your data. Technically, it's how much each number changes from your mean, from your center, right? So an easy example is just making k equal to 1. In A, all of my values are going to be 1. So your standard deviation would technically be 0. There's no change across your data. This would be your lowest possible standard deviation. In B, we would get -3, -1, 1, 3, and 5. Compared to A, huge change across my data, right? I'm going all the way from -3 up to +5. There's not a single consistent value here. I'm already guessing it's going to be B here. Tons of change across our data. In C, we get -1, 1, 1, 1. You can already guess this is going to be much lower standard deviation. 3, notice how my change across my data is much less. Not going to be that. And finally, D, we get 0, 0, 1, 2, 2. Again, much less standard deviation. They're always going to give you an extreme example like B. That's going to be it. Number 9. An exponential model for the number of newly mapped stars in a distant nebula estimates that the astronomers identified 520 stars in 2003. Sounds like an initial. And at the end of each 4-year period for the next 20 years, so if it happens every 4 years for 20 years, I'm thinking of a number 5, but we'll get to that, right? The number of mapped stars was 180% more than the number at the end of the previous 4-year period. Okay, I think we have an idea of what's happening. Which of the following equations represents this model where S is the number of mapped stars, T years after? Okay, so I want to focus on the T years first. We can see that the initial is 520 in all of them, so that's not going to help. So I'm looking at 4T versus T over 4. So remember, if it's happening every 4 years for 20 years, after 4, after 8, after 12, 16, 20. So that's where we got the 5 from. This 180% more should happen 5 times when T is 20. So if I plug in T as 20, I'm going to get this weird 80 in both of these, right? But over here, I'm going to get 5 and 5 because the increasing is happening 5 times. So we already know it's C or D. And then some people might be thinking it's C because I see the 180%. But we want to remember our binary percentage rule. If it's 180% of, then it's going to be 1.8. If it's ever 180% more than or increased by 180%, you have to add 1. It turns into 2.8, and it's going to be D here. Number 10, we have an x function with a k integer constant, and they want to know what the value of x to the k is. If someone has a Desmos solution, definitely post it in the comments because we're just going to do this by hand. So we always want to get rid of this radical. So I just raise both sides to whatever number's there. So it's going to be raising this to the 2k, raising this to the 2k. Our left side becomes x to the 2k. And then our radical, whenever you raise it to whatever your radical number is there, it cancels out. So this is just equal to 3x to the k plus 10. And then naturally, we want to get everything to one side so we can factor. So it's x to the 2k minus 3x to the k minus 10, and it's all equal to 0. And this is actually just like a standard factoring problem. When we set up our parentheses, we have x to the k and x to the k, because when I multiply x to the k times x to the k, it's just x to the 2k. And it's just going to be, you know, what adds to -3 that multiplies to -10. And that's just going to be -5 and plus 2. And this is still equal to 0. So it's just x to the k is equal to 5 and -2. And it actually can only be positive 5 here, because if we say, since k is a positive integer constant, let's say k is equal to 1. So therefore, x to the 1 would be equal to negative 2. So I could say x is negative 2 up here. Well, how could I take the square root of something and then end up with a negative value, right? So that's not going to work. So they gave us 2 values, but it's kind of tricky. You can only choose one. It's going to be positive 5 here. Number 11. A player in World of Warcraft is tracking how much gold their guild has. The initial amount of gold in the guild bank is 1,600. The player sets a goal to reach 3,000. The player uses a model that says the guild bank starts at 1,600 and increases by 120 gold per week for the first 2 weeks after the initial, and then increases by 180 gold per week until the goal is reached. According to this model, at the end of week T after the initial, where T is greater than 2. And we can pause there because that inequality is going to be really important. So we would try to categorize this as a linear equation problem where your slope changes. It's only 120 for 2 weeks, and then it's 180 for the rest of the time. So your goal here is, you know you did it correctly if your final equation has 180 as your slope. So I'm going to open up Desmos because it's just going to be a plug our 2 points in and get our line. But we want to be careful with those 2 points. So since they said t has to be greater than 2, or our weeks, I'm just going to say week 3 and week 4. And to calculate that, well, we started with 1,600 in week 0. We add 120 for week 1 and week 2, and then we add 180 for week 3. Week 4 is going to be just a little bit different. It's still week 0, week 1, week 2, week 3, and then week 4. So if I graph this, I know I did it right because I got my 180 for my slope. Now I'm going to jump back and we can write down that equation. Y is equal to 180x, or t, plus, what was it, 1480. And then it's weird because I don't see my answer down below, but let's just make sure what they say here. They say, gives the predicted number of gold still needed to reach the goal. So what does our equation give us? Let's jump back here. And my graph is really steep, so it's actually not going to help us. Like, I can't look at points on it. So what I can do is I can bring this down. I can make this f of x, and I can say, well, okay, at week 3, what number are we getting? And we get 2020, and we just have to think, oh yeah, so when I'm at week 3, we have 2,020 gold, but they want to know how much gold we still need. So if I had 2020, how would I figure out how much gold I still need? Well, I just take my goal of 3,000, and I minus the 2020, and this gives me how much gold I need. So that's kind of the direction we want to go. You actually take your goal, you subtract the equation that we have, and this should give us what, or rather how much gold we're missing from our goal. So if we do this, I do 3,000 minus that gets me 1,520, and then minus 180x. If you want to double check if that works, you can just make another function, g of x is equal to this, and I can say, well, at week 3, how much gold do I still need? And that's correct because we have 2020, we still need 980. I jump back and I look for that 1520 minus 180x, and I can see that's going to be my answer choice, C. Number 12, for a linear relationship between A and B, the table gives 3 values of A and their corresponding values of B in terms of a constant K. What is the slope of the line in the AB plane that represents this relationship? Okay, so again, it looks like we have 3 coordinates. I got 3 x's I could plug in, 3 y's I could plug in, and I should be able to get a line from that. So we'll open up Desmos, we'll make a table, and I'll plug in exactly what's there. We have when A is 4, B is K. When A is 10, B is K minus 108. And finally, when A is 22, B is K minus 324. Now this looks like there's a problem, but that's just because Desmos doesn't know what K is. They said that K is a constant, so I'll just say, okay, well, what about when K is equal to 1? Notice how those cautionary signs go away, and I can just graph my line. And we can see our equation here. As I change my K value, my slope is constant. My slope is going to be negative 18. I jump back to the question here, and I can see it looks like our answer is just going to be B here.